This is going to be a presentation on a concept called infrastructure as code. And what this really boils down to is like a lot of times when you work in the cloud system, we'll be introduced to this later, you're having issues where like you're kind of clicking through consoles, everything feels like you're doing it over and over again manually. And so what this does is it takes away that process and it makes it so that the same process you use to develop an application can now be used to deploy an application. So those being two different entities. So that is the basic setup of this talk, and we'll walk through that. And then for myself, this is a little bit of background. I've been working in AWS for a little over a year now, specifically around data engineering. And for myself, I do not want to be a DevOps person. So I know that's like a concept that, for those of you familiar with the space, like CloudFormation is often associated with DevOps. The way I look at it is CloudFormation is an ability to shortcut stuff so that I can have a repeatable process that I can quickly set up in a new environment. And so that was what motivated me as a data person to want to get into something that's often associated with like roles about configuration and other things that I don't like. So that's what motivated me to get into this. And going from there, we're going to go starting with just a very brief introduction. For those of you that are kind of new to AWS, like we're not going to dive deep. Like this is going to be more like what is some concepts around AWS. We're going to move into the basic structure of infrastructure as code, and then step through what that looks like in the AWS environment and how to use and apply that. So that's going to be the format of this talk. And so now we're going to talk AWS. So when I'm looking at AWS, I tried to find good quotes from smart people, and I didn't find any good quotes from smart people. And so like this is what like it boils down to for me. So like all this buzzwords around cloud and stuff, like originally started with like hardware on demand, and the reason it's possible is because of the infrastructure that built the internet. So like in the past, like if someone wanted to increase the amount of storage that they had at their company or something, they would go and order a server. It'd take like 6 weeks for that server to come to their company. They would then have someone come in, configure that server, stand it up, ta-da, now you have extra storage. Super painful process. And now you're paying for that indefinitely because you have that storage going on forever. What the cloud did to change that process is it basically made it so that through the internet, you can now just turn on that storage and turn it off at the click of a button in minutes. So that is fundamentally why cloud services are so popular now. So as we're talking through that, and we're talking specifically around AWS, like I want to go ahead and just like introduce you to like AWS is built around a bunch of services. Now, who here has worked with like a virtual machine where they had like a Microsoft or like a Windows system or like a Mac system, and you're like, oh man, I needed to use this like other service, and then you use like, I think it was like VMware or whatever it was. Like, so that was like a service that was used. That's fundamentally like what this service called EC2 in Amazon works. So this is one service in AWS. Now, what happens over time is progressively Amazon has made more and more complex services built out of those other services. So an example of that is another service that is, this is just a database for analytics. It's called Redshift. And in this, like you see each of these units where these blue squares represent like different virtual machines. So what those virtual machines are functionally under the hood are just a bunch of EC2 instances. So now we've stepped from a single service that had a single functionality, and now we have a service on top of a service. So it's almost an aggregator. So we're seeing this complexity build, right? So then let's take this one step further so we get more overwhelmed. All right? So when we're looking at this is not a wild like design pattern to have. realistically, all that's happening here is like, this is a format for like what we would say like is like an ETL pipeline. And so it's like you have a bunch of data coming in, it's landing in like each of these different databases. Now, what I want to highlight here is that one Redshift service that we talked about. So we went from an EC2 instance, which was one concept. Then we built on that and we made Redshift, which is like basically a bunch of EC2 instances working together. And then now we've got this entire service of services, like for all these applications, and we're looking at this, and you're just like, wow, now we're in a problem, all right? So we have a bunch of like really complicated stuff, and how do we manage all that? And let's take it one step further. So when we're looking at that, here are all the services that AWS provides currently, each one of them at a level of complexity more or less similar to the two services I described right now, EC2 and Redshift. So now you're getting really complex, and we have to figure out from here, like, what do we do with this complexity? Yeah, what's up, Matt?
Can you discuss the delineation between the use cases for Redshift as opposed to EC2?
So
the core things that like kind of everything feeds out from that.
Yeah, and so like you think of EC2 as like the base unit that everything is like it's basically your functional unit. You can configure it however you want. Whereas like the application or basis for like Redshift is like specialized for a specific purpose. So like the Redshift service is like, it is designed for being an analytics database. It is not designed to be like a transactional database. It's not designed to be a web server. Whereas an EC2 instance is a base unit, and you can make an EC2 instance into a web server. You can make an EC2 instance into an analytics database. All these different like examples of things. And in case it wasn't clear, please ask questions along the way as you go, and you're like, hey, Blake, you don't make sense. So we'll go ahead and go from there. So we're dealing with this complexity. And when we're dealing with that, we have to figure out, like, what do we do? And this is where the concept of infrastructure as code comes into play. So we've seen all this complexity starting to take place. We're trying to figure out how to manage it and make it repeatable. And what is the concept of infrastructure as code? So functionally, I like to describe it as the ability to write like structured scripts in like data formats such as YAML or JSON, and you use those in order to build out different services in whatever cloud platform you use. So remember, infrastructure as code is not something specific to AWS or specific to Google Cloud Platform or anything like that. Infrastructure as code is a principle that can be applied across all these services, and it's a way of managing complexity in a nutshell. So this is what we're looking at for infrastructure as code. And so it's like, why are we using this service? Like, why go through this process where it's like, I can already manually click through and set this stuff up myself? The reason why we'd be looking at that is like teams that go ahead and like do use infrastructure as code as a process, now you start to get into standardization, you start to get into repeatability, and you avoid like the process of like having to like, you know, let's say you started one project where you built a web server. Then you just go to a new company. You want to build the exact same web server. What you would have to do in that setup is essentially you'd have to click through all your services with your mouse, go into each of your options, and set it up again. Infrastructure as code removes that process, and that if you write everything in scripts, you can then deploy it in one service at the click of a button, and then deploy it in a new environment at the click of a button. So this is where infrastructure as code has its value. As we move on to infrastructure as code, I want to go ahead and talk specifically about the AWS environment. So in the AWS environment, we're using a service called CloudFormation. So what CloudFormation is essentially AWS's version of infrastructure as code. Now, I want to make a distinction here. So infrastructure as code is the process we've been mentioning this whole time. There is another thing called infrastructure as a service. CloudFormation is infrastructure as a service. And that it is basically a type of infrastructure as code. So these are buzzwords that get thrown around. So think infrastructure as a service is like underneath infrastructure as code. So we're getting into concepts. Does that make sense to people so far? Okay, cool. Yeah, Nick.
Is a good example of infrastructure as a code, like something like Terraform?
Yeah, so that would be another example where it's applying infrastructure as code, and then Terraform would market itself as infrastructure as a service. So yeah, so that Terraform would be an example. Red Hat's Ansible would be another example of infrastructure as a service, where they provide the platform to apply to use this process. All right? So as we're moving into CloudFormation, what is CloudFormation? So we've seen this like here I'm like blabbering on about this process, and it's exactly what I've described so far. And so what like the value of this is like it's a text file that you turn into AWS services. So as we're walking through that, specifically, CloudFormations can be built on YAML and JSON. So everything that we've seen introduced so far about infrastructure as code. Now, as we're going into that, we've gotten one why, where we see infrastructure as code. It's maintained infrastructure as code. We've seen that. I've said the word like 300 times now. And so we're going to go ahead and see here is I want to highlight that this is a process for like getting templates to produce your application. So you're writing code to produce all the background information that like in the past you'd have to click through and set up. So now when we're looking at this, one thing that is huge about this is version control. So for those of you, like you're using Git to manage your code, and you have that one time that you're like, oh boy, I should not have deleted that line of code. Like, I've had that moment far too many times. So when you're looking at that process, like this is where the version control here, you can add and remove units and then track over time what adjustments you've been doing to your application to, let's say you wanted to optimize a process. You can add and remove services from AWS or tune them and track those changes. Whereas in the past, if you're doing this all through the console, you're just like, wait, what kind of instance was I using? Oh, wait, how did I set that up? What service was connected to what? This is making a process so that you can track those over time in like a Git repository where you store your templates. And then finally, you can use this in a CI/CD pipeline. So CI/CD is continuous integration, continuous deployment. And so it allows you, I have not done this myself personally, but it allows you to be able to deploy these templates and have those go out into like the production environment, just like you would with like normal code sent out to build a web application. So it's almost like before you were writing code, raw code, and it would build stuff. Now you're writing code that sends out to services that are built on code. So it's like this crazy meta complication stuff. So questions about that so far? Yes?
So the version control aspect of this, is that just simply, since it's a text file, I can version control that in Git, or does AWS offer any additional version control and support for CloudFormation?
Right now, I believe you can use code deploy with CloudFormation, but you would have to double check me on that piece. And so for integrating there, as I've used it so far, I've only been using Git, and then I'll kind of walk through my process of how I've managed and deployed my templates. But I have not done CI/CD myself personally with the process. I just know it's a viable option. So maybe a Jenkins job or what have you. So yeah. Yes?
So when we write code, if we mess something up and we deploy it, we can roll it back. Can you roll back CloudFormation changes?
Yep. So yeah. So you can have exactly the same thing apply here. And that is one of the values is, in the past, you would just click it and you drop down and maybe you remember what you made. But now you can see like a trail for that. So, and you can look at the deployments in CloudFormation as you go and see the template that was deployed. So you can see the specific changes. So, cool. And then, so this is like functionally how CloudFormation is working and walking forward. And so when we're looking at this, you write your code. It has to land in like AWS's like storage, major storage, S3. And then that is picked up by CloudFormation, which then reads through that JSON or YAML file. And then from that, under the hood, what it is doing, from what I'm told, which could be wrong, but I'm pretty sure it's right, is it's taking various Lambda functions and it is using those to deploy those different AWS services. So this is what's happening under the hood with CloudFormation. So it's basically like, yeah, it's a file that's telling it, hey, go click through all these buttons, but with code. So when we're looking at that, we're going to walk into a template. So as we're walking through a template here, we're seeing, I want to highlight a couple of major pieces that come with like this. I'm using YAML, and the reason I use YAML preferentially is one, in YAML files you can add comments, which is really helpful when you've got like 200 or so lines of code and you're like, wait, what was that service for? So it's really helpful for being able to comment code. It's also just less like writing of like curly braces. I used to like JSON, and then now I'm like, I don't need 20 curly braces like going on everywhere. So I'm going to show you YAMLs throughout. And so the first section is just description, exactly what it sounds like. Parameters. So parameters is a value that's going to come up later, and I'm going to show you where this is really valuable in nested stacks. And so this is where you can have runtime variables, essentially. So when you deploy the CloudFormation, it's going to ask you for these variables, and it's going to be like, hey, what type of EC2 instance should I use? What should I call this service? Like, how should I configure this like Redshift cluster? Like, you could pass variables into the CloudFormation through the parameters. Yes?
So if you have things that you don't want public, like API keys or other secret keys like that, and it's my understanding, like for different services to connect to each other, they need to know the locations of those, or like the secret identifiers of them. So like, is there kind of like an environment variable that you can pull in from here as well?
Yes, and we'll talk about this stuff in best practices. But yeah, you're already on it with like avoiding putting valuable information in explicit writing. So now, and then so resources and outputs. So outputs are valuable for a concept called cross-referencing stacks. And so resources are the actual AWS units. And we're going to talk through each of these. I'm just going to move through these pieces. So this is going to be an example of your parameters. So what you do to define this and highlight here. And we'll have this deck shared out, so don't worry about taking notes on this stuff. But really, I want to highlight is that there's this default value. So if I pass nothing in, this is going to be the name of my Lambda function for the example. Like if I'm like using the command line, I prefer using command line So that way I'm not messing around in the console like at all. I write all this stuff on my computer and I deploy it up from there. So it's really helpful for managing everything through Git, deploy on the command line. And sometimes if I don't want to define the variable, I can put a default value. Description for people that don't know what your stuff is by themselves. You can constrain the data type. And then you can also add a list of like allowed variables or allowed values that can go in for specific variables. So I'm going to move through that and then resources. So here are examples of resources. What I want to highlight here is like you can end up with a lot of resources, and managing all of those can quickly become a beast. And that's where like a lot of this conversation is going to be where the value of CloudFormation can be and how you can manage all those resources in a way that allows you to use those units in various other applications. So I'm just showing you an example here where all we're seeing is the type of resource used. And then you configure. This is where rather than me writing all these numbers or clicking through like screens to set these things up, this is all there available for me. So outputs. Now, these start to become really valuable. So where outputs come into play is this allows you to export values from one CloudFormation. They call them stacks. So a stack is like one template file that has been deployed that deploys all these resources. So when you're looking at that, this allows you to pass from one stack to another stack information in between those stacks, okay? So we're gonna look at what that looks like, and then I'll pause for a second to talk through that. So looking at this, the way this is used is cross-stack resources. See, I was wrong earlier, if you all remember. So, and so when you're doing this, one way to manage CloudFormations is like you might be able to have a way where you deploy one CloudFormation that deploys a bunch of resources that another CloudFormation needs. So you like can build in layers. So this is what cross-stack resources is doing. So you deploy one stack, then you deploy another stack, and that stack takes information from the one before, okay? So that's what this is doing functionally. So when we're looking at that, I think for myself, I'm a very visual learner, so I've got a lot of words on the screen here. Let's just show you what it looks like. So here is the first stack, and here is the output of the first stack. So this is telling me I have this value here. I want it to take this information from this troubleshooting, this is short for security group. I want that value to be exported with the name account security group. Okay, so this is stack one. So stack two is then going to be building an EC2 instance where when you're looking at these, so an EC2 instance, like we talked about before, is a virtual machine. It needs to be landed in like a security group basically provides access to that EC2 instance, and every EC2 needs a security group, okay? So sorry for throwing a little bit out here. But with that, it needs that security group. So stack two is saying, hey, I want the account security group information from stack one. All right? So do we see how this might be applied, like in between stacks and everything? Okay. So any questions on this? Yes?
What does TSSG stand for again? Is that like an arbitrary name?
That's a completely arbitrary name. So for whenever you're reading this kind of stuff, so like if you remember from the start, the highlights was the parameters, the description, the resources, and the outputs sections. So we had these 4 sections. And so we're looking at the output section. Here's a name of an output. You can make it whatever you want. Here's a resources section. Here's the name of a resource. You can make that whatever you want. So when you're building these CloudFormation templates. All right, yeah.
And then what is a rule of thumb on how big to make a stack? So like if I have a web server and a database talking to each other, can that be in the same stack or should that be broken up into two different?
I love your question because it's leading right into my next point. So we're going to be talking about nested stacks, and that is exactly what you do. Is break it out into distinct units where you can now manage it based on the material that it's working with. So there might be a security stack, there might be a user roles stack, there will be a database stack, there will be all these different stacks that all work together, and I'll show you how those look. So as we're going through this, this is where, now when would you use a cross-stack reference as compared to nested stacks, which is our next concept? So you use this when you want to use one stack, like a virtual private cloud, so a VPC, might be used by multiple resources, multiple EC2 instances could use the same VPC. All right, so that's one to many. This is where you'd use this service. All right, so cross-stack resources. So one to many, just remember that with this. Whereas now that is Adam, and then sweet, now that Adam has set me up with an awesome little transition, we're going into nested stacks. So what is this? Stacks created as part of stacks. We're just going to keep getting more and more meta, all right? So we started with what is an AWS service, and now we're going all the way into writing code, all right? So bear with me, and we're going to see this stuff through. Now, are there any questions about cross-referenced or cross-stack resources, what a CloudFormation is so far? Cool. So this is what it looks like overview. All right, so we have a root stack. Okay, so remember this term, a root stack, and then a nested stack, where you can have multiple nested stacks kind of branching out from a single stack. Okay, so we see this single stack that is going to deploy all these other different stacks. Okay, so I'm going to have an example of this that I'll show you, and this is where I think this is really valuable to just kind of show you what this looks like in an actual coding environment, so how you would manage your code. So can you all see this okay, kind of? Okay, apologies. And so what we're seeing here is I want to show you this is a root stack, okay? So when we're looking at a root stack, there's going to be this information. It says, what type of resource is this? This type of resource is a CloudFormation stack. All right? So it's what we're deploying is a CloudFormation stack, not an EC2 instance, for example. So when we're looking at that deployment, we have in here the big things is, so now we have our root stack, and it's telling it, I want you to deploy, what do I want you to deploy? This other stack. And so where is this other stack? Now, this point right here is why I wanted to give this talk, because this took me weeks to figure out, because nowhere in the AWS documentation does it talk about what we call relative pathing for deployment. So notice how I just say step 1 VPC YAML, all right? So if you look where this one is, it's going to be pointing at the other stacks. So every one of these, step 1, step 2, step 3, step 4, step 5, step 6, these are all different CloudFormation stacks that are being deployed by one single stack. So rather than, so if you remember, so whereas before, what would we have done? In this case, we would be deploying one stack, then we would deploy the next stack, then we deploy the next. So you see where this becomes valuable. Now we're only deploying one that deploys many stacks at once. So when we're looking at this, we're going to see this process moving through. And so it's pointing to this other stack, and it says, go ahead and deploy that. That's where we want to leave that information for right now. So that's what I want you to remember. Root stack deploys other stacks, okay? Nested stacks. So when we're talking about that, like, what is it that makes, like, so we've now gone from one big template that was like everything. Now we have the ability to make multiple small templates and deploy them in units. Yeah, so the question is like about like what, like, can one stack's information be passed to the next stack with a nested stack? The answer for that is yes. So if we want to look at that, we're going to go ahead and see here. I kind of glazed over this, but we're seeing step 1. Here's the parameters going into that stack, okay? And then we're going to look at, I don't have it in the screenshot. I'll show you in the actual deployment. But basically, you can have the output of one stack go into as the input of the next stack.
Is that why the depends on keywords?
That is correct, yeah. So you put the depends on, because then what happens is like AWS CloudFormation looks at it and says, oh, depends on, all right, I need to go to the one above it, and I need to deploy that first. Yeah.
But could it point to another one? Yeah, that would be crazy, right? But still, do you say that the step 3 still depends on step 1? Can you put?
Yeah, you could put, depends on is basically to make it so that that stack is always deployed after the stack that it depends on. So like so step 2 depends on step 1. So step 1 has to be deployed first. Yes.
What happens, like, since 2 depends on 1, if the build for step 1 fails because you mistyped something or forgot some specific thing that you needed, what does it look like? Do you get helpful error messages, or is it?
You do get helpful error messages, and I'll show those in the console. And then to Adam's point about rolling back, you asked that a little while ago. So if step 1 failed, then step 2 would not go forward. Or if like step 1's good, step 2 failed, and then what would happen is it would actually do what's called a rollback, and it would remove step 2 and it would remove step 1. So that way you don't end up with resources that are just sitting there stranded in your AWS group, adding cost. So now everything is collected as a unit together, all the different services. Yeah.
When it does rollback, does it take a backup before this running this execution of scripts? Then it runs again the older one.
That's
Rollback happens.
yeah. So when a rollback happens, like basically, does it like make it go back to the beginning? And the answer is yes. So it will go all the way to the beginning of when you deployed the root stack. So remember, this is all the root stack happening. Yeah. Yes.
So I understand it rolling back in case of like a error, but let's say we have a web application and someone goes into the security group into the CloudFormation template and removes 443 and 80, and now we can reach our website and then they deploy it. Can I roll back even after the deployment?
Yeah, so you could actually write code, put those ports back in, and then you can deploy it and adjust resources that were changed.
Okay.
Yeah.
It's not automatic. If the change set goes out and it's a success, there is no rollback that is built in.
Gotcha.
You will have to make the change to the template yourself. It's a manual rollback. It's possible. But it's only in the case of failure.
Yeah. Yeah. So now we're working through this. So we've gone through great attributes here. A couple of bullet points I want to get through pretty decently is I just want to kind of click through and highlight a couple pieces here. I'm not going to talk through each one of these. So nested stacks, if you just remember that nested stacks is a one-to-one relationship. As like cross-stack resources, one-to-many. Okay? So this nested stack is where you have one VPC stack to one EC2 instance. Whereas if you wanted to have one VPC stack and then multiple EC2 stacks pointing at that one VPC, this is not how you do it. So this is intended for all these resources to be packaged together as one unit, one-to-one. All right? So when we're looking at that, and then this is just going through a couple of things of why this is nice. All right? So with that, I feel like I've been talking at you a really long time. Super sorry. Hopefully this is helpful. I want to show you what a deployment looks like. So what we're looking at is, cool, I figured it out. So the cool thing I want to point out here, so this is inside of the CloudFormation console. So if you remember from what I was showing you for the example, yeah, I wonder actually, can everybody see this okay? Okay. So when we're looking at this, what I want to highlight here is I have my root stack right here. And look at all these keywords of nested, 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 nested. Each one of these nested stacks depends on this stack right here, the root stack. Okay? So this is in the CloudFormation console. And this is where I really want to describe the strengths of this, and that this stack right here is going to head, and here is all the resources that it deployed. So the different things, think Redshift, think EC2, think all that stuff. So here's all the resources it deployed. And then we're going to go to its nested stack, where these are all the resources that just one of those stacks deploys. All right? So you're starting to see, now we've managed all these complicated, I've just deployed in this single root stack deployment, I deployed 50 resources. So all these different, and they're all managed together as one unit. So this is what it looks like in CloudFormation itself. And there are other things in here. And so what that is doing, and now I want to get back to how this is deployed. All right? So I've just shown you what it looks like in the console, what's going to be deployed. And then right here is talking through how to deploy it. All right. So again, these slides are going to be shared out. All I'm showing you here is this is a bash script. So for your terminal, and all I've done here is there is this one command. Now, for those of you that have worked with bash and everything, most of us, maybe I'm assuming, have done some terminal work. Look how many flags I'm having to put. This is a pain. All right. So I could actually go into the command line and just pass each one of these variables or pass one of these key value pairs. Well, it sucks. So all I've done is I've written one single bash script that makes it so that when I, let's see if I can do this real quick. I have, cool. So what I have here is I'm going to have, okay, so, sorry, that's zooming in a little bit. So basically, from the terminal, what I want to show you is rather than me writing out a big, massive thing, it's going to go ahead and I'm just going to do sh, and then I would put deploy sh. And then if you look, I'm inside of here, and so it is deploying that big long file that I showed you earlier, okay? So rather than me writing all of this out manually, I just keep it in a file, and I just say deploy, sh deploy, all right? I do the same thing to tear a stack down. It makes it way easier, So this is one of the things I wanted to highlight and bring to your attention for how to do this from the command line. All right, any questions on that so far? Yes.
How often are you running a deploy script?
For me, when I'm in development, I mean, I'm just like, as I'm working along, I'm doing it like every 20 minutes or so. Because the thing that happens is when I'm writing and I'm sending out this deploy script, what it's doing is it's not going to create it's not creating every resource new every time I send out the deploy. So I'm not sure back here had mentioned, there's going to be a change set that's going to be created. So I say deploy. It's going to look at my template, and it's going to see what resources have changed, and it selectively updates only those resources. So so that's something I want to bring to your attention. So when I deploy this root stack, it's going to look through, look for changes, and only apply the changes. It's not going to redeploy all the services again. Any other questions?
I was
Yes.
wondering, you have the environmental variables in the actual file here. Do you, is there a common tool or strategy for if you want to keep those in a separate place and pull them in?
For the bash script in particular?
Yeah. Or is it just not that you would have super sensitive?
Yeah, this wouldn't be super sensitive information. This would just be information about what the stack is called, where you're deploying it.
Or an API key?
No, so the API keys and all that would be managed elsewhere, up in AWS services. So, yeah, cool. Any other questions? Cool. All right. So that's how we deploy, and then so I'm just showing you that script. That's all it was. I don't want to dig into this very much, but I'm just showing you how you can use this to speed up your development. So the next thing is the undeploy. Literally the opposite. CloudFormation, delete stack. All right? And this is how you tear down the whole stack. So I have one undeploy, one deploy bash script, and I just sh that, sh this, build it, tear it down. So this is where it's nice. And then I just wanted to go through and just highlight that in my project structure. So I'm just bringing that structure back again. So again, this is how I build my stack, sh deploy. This is how I tear it down, sh undeploy. And then here is my respective root stack and nested stacks. Cool. Is this starting to feel a little bit more manageable, less intense? Okay, cool. So I want to show you here on that whole series of nested stacks that we just watched. Here is everything that got deployed. So when we literally just wrote sh deploy, this is everything that got created. So we just built an entire ETL pipeline with one click of a button in 20 minutes. So that's pretty cool. Once you get this, so you build it once, and now you can apply it in multiple environments. New job, new project, new company, you can have the same deployment up in 20 minutes. So here we have some value to that. And then from here, are there any general questions about a nested stack? Are we feeling, yes?
So have you found any comments on basically, are there situations where you're tearing down your stack and you still have resources, vestigial resources still hanging out in AWS, costing you money? Is a true delete stack always going to completely delete the resources you just created?
So it will always delete, but what it will tell you if it fails to delete, and it'll tell you what service it does not delete. And I'll get into some of this on best practices on how to manage that. The only reason one of the main reasons that a stack is going to fail to delete a service is if you don't have that explicitly defined in your templates. Okay, so if I create So for instance, the stack that I've been showing you as an example, I could not delete the VPC because another service had created something associated with the VPC, but it wasn't written in the template. Once I wrote it in the template, it was like, oh, I know it exists, so I know to delete that as I go. So we have that.
Can you,
Yes.
I was gonna say, can you build something into your undeployed script to account for that? Like if you know you're gonna be like creating an extra resource that isn't being spun up in your deploy script, can you tell them about it in the deploy script?
You can't do it through the script, unfortunately. But yeah, like this is something that's like gonna be like in the template, like you can point to existing resources as well. So you can tell your template like, hey, like use this security group that already exists on AWS. So that way it recognizes that that exists. Yeah, go ahead. Okay.
So when you go to delete a stack and try to delete resources, it'll almost always get rid of it. There's certain situations where it may actually lose something because it can't delete it, and you finally say, don't even try anymore, I'll take care of it. But you can define, when you define that resource in the template, you can say specifically, retain this even if I delete the definition. And that's a really smart thing to put on things like S3 buckets, which actually you can't delete unless they're empty, or like RDS databases. You would want to leave a database around just in case it got deleted out of that template by accident. You wouldn't want to also use your database to fit passive values and things like that. So there are specific situations where you can set that up. So it'll specifically retain these things. And there's some very good reasons for that. But generally, no, it should get rid of everything. Unless it fails, then you can say, well, don't try it.
So, and then, yeah.
Go back to the architecture. I'm just going to discuss similar architecture of this working on that. I just go to-
This right here?
Yeah.
Yeah.
So the compression, for the compression you are using lambda function, if a data set can able to do the kinesis there, the compression can happen in the firehose?
So like connecting these two kinesis groups.
Yeah.
So because it's passing through a Lambda function, you can link Firehose to a Lambda function, but you're right, you can't directly connect Kinesis data streams to Kinesis Firehose. But because we have this middle piece here, is that answering your question about connecting these pieces?
So what is the middle piece does? Because data seems able to connect to firehose, and I'm just curious, what is it lambda function does it here?
Yeah. So what the Lambda function is doing here is basically data enrichment. So it's adding information to the data that's coming in. And so, which is like a pretty common practice in like ETL.
Okay, great. And also the compression here, we are smaller file we are compressing to the larger file, right? Here the raw S3 to the script bucket.
Mm-hmm.
So that is for the EMR is not too expensive. I'm just curious because similar things I'm just working on that. To compressing the multiple files in single file, is the EMR will be expensive or other options?
So what this is functioning to do is just basically to append and convert those. So it's not really doing the compressing.
Yeah.
And then, so I don't know about the cost on that one, unfortunately. Sorry, so I'm still learning these things. But yeah. And then, and that is, I kind of wanted to go through and I'm just going to highlight some points on these slides. I'm not going to go through each one. One thing I want to highlight about here is like now we've seen when to use CloudFormation and how exciting it is and how you can write everything in CloudFormation, but you shouldn't do everything in CloudFormation. This is where I want to highlight here is that a good rule of thumb to deal with CloudFormation is let CloudFormation deal with things that are static or change very rarely, all right? So services that once you set them up, you're not adjusting them a lot, okay? Whereas, like, anything else, you should manually configure. So going back to this pipeline example that I have here, I configured all of this through CloudFormation because once it was set up, it was going. all right? Like I wanted this whole pipeline. I didn't want to adjust things to it. This right here, I actually put into another service that required a lot of configuration and a lot of adjustment, and I did not put that service. It was called ECS, and I did not put that service in the I just manually configured that, but I put all of this into the CloudFormation because I knew those things were not going to change. All right? So this is just a word of caution. If you feel like you're adjusting something a lot of times, you probably don't want that in a CloudFormation. All right. So when we're looking at that, and then when we're doing this, the things to watch out for, so along those lines of like why would a stack fail to delete at times? So we see things like what was mentioned here about like S3 having data in it. It won't delete that in there. If you have a VPC that has dependencies on it that like are not created in the stack, it won't delete there. Just in general, if you're configuring resources through CloudFormation, stick to adjusting them through the YAML or JSON file. Don't go in and then adjust the resource manually like in the console, because it could make it difficult for it to roll back or delete those files when you delete the stack. So that's really what I want to highlight here. That's all I'm going to say on this slide. And then, are there any questions about those best practices so far? Okay, and then we're just cruising through these last ones. And so when we're doing this, I have a lot of words here. And all I want to really say is like, basically with nested stacks, like take advantage of your like outputs, take advantage of your parameters, all right? So parameters to feed in, outputs to feed out, okay? So that's what I want to talk about here. And then to Fenton's point here, I wanted to mention don't like put your credentials in the templates. So again, these templates go up into S3. It is possible to access these and see that information. You don't want that information sitting around, so API keys and what have you. Here are 3 different ways. Or 2 different ways you can go about like that. You could do like a no echo property, so the template that's deployed in CloudFormation will not retain that variable's like details. There is the AWS like SSM, which is secrets manager. Yeah, I always blank on the real name. But anyhow, like that's a service that in CloudFormation you can use it to generate passwords that aren't into the template. So there are ways to work around putting information in. So no echo being a very important one to consider when you don't want that information out floating around in the CloudFormation service or in the S3 template. All right? So, yes?
So if a DB password I need to pass it to connect to any database, then it should be encrypted. That's what you meant to obfuscate, or how do I pass that password?
How do you pass in a password for a database? So for something like that, you could do like either an SSM. Like if you have an explicit one, this is where if you would put it in the template, deploy it, but you'd have this no echo property, and then CloudFormation will not, the template on CloudFormation will hide that information.
Okay.
So
in a template, I have to put the password directly, or it can be encryption speaker?
if you're putting it on your command, if you're developing it on your computer and you use that deploy script that I showed earlier, that this will all be shared. If you deploy it, but you have this no echo property, it will not be in the template that's on CloudFormation. Yeah, so it'll be hidden through there. So, so those are some practices. And then, yeah, treat it like code. Like now we've learned how to use these. We've learned how to develop them. We've learned how to like version control these. And then we see how to break this up into separate units. Okay? Now, wanted to get through that because, you know, we covered a lot. And I wanted to open some space to ask a couple of questions. So yes.
So I feel a pretty common scenario is someone not having used AWS, but not having used CloudFormation. Is there a way to generate CloudFormation templates based on what you already have built?
There is a beta service called CloudFormer. It's not great. But yeah, so that is definitely a space where I think you can do these. Someone in the room maybe could speak to this, but like through Ansible, you can do services, like build templates from services. I think so, but don't quote me on that and check it out. But right now that is a constraint in that like if you have existing services, like it is difficult to export those services into templates. So you kind of got to start with the templates, moving into it. What I do a lot of times for my development so far is I'll build them in the console, figure out what those variables are, I'll write it into a YAML, and that way I have it like as a defined template that I can use in the future. So I look at this as like something to use 2 or 3 times, not once. And then, yeah. Any other questions? Yeah.
I've got a bunch, I'm sorry.
Yeah. No.
Do you any tests for your CloudFormation templates?
I don't right now. And so
Is it possible? I have no idea.
test as in for,
So like if we're treating it as code, then
yeah.
it makes sense that we would write a test for it, so if someone changes it in a bad way, we can be notified before we push it out.
I don't know much around that space with like testing. Like I just like, so I know for managing templates and making sure that they're at least within the correct syntax, like for Atom, like the IDE, there are like template, making sure that templates conform to what is currently available for those. So as you write it, like you have like a linter that manages it, but and then there is also in the AWS service, you can deploy a template. I forget what the keyword is, but you can actually through AWS validate a template. And so you might be able to use that template validation.
Is that TaskCat? Does that sound like TaskCat?
It doesn't sound familiar, but
I just Googled to see if anything came up, and apparently AWS has like an internal service called TaskCat.
Oh,
that
gotcha.
you can use to do some testing of it.
yeah, and so that would be one of these services that like, so I guess it's TaskCat, and then, but that's the AWS service to like validate a template. So you might be able to figure out a way of doing like some sort of code validation, putting it into Git. But yeah, that would be a thought process. Yeah, James.
You're listing off a few things that were not good times to use infrastructure as a code.
Yes.
You said that you're changing things a lot.
Mm-hmm.
Wouldn't that be a great time to use version control the most?
So it's good as you're developing. So as you're changing things a lot when you're developing, but eventually like you want to get to a point, like in development when you're deploying it to production, then it stops that. But like let's say like you had something where you're like, you know, it's an ETL pipeline and you're tuning it constant, like tuning one service, like constantly, like tuning it up, tuning it down. That is not a good use case for CloudFormation because like you're gonna have to like either pass that through the template and then deploy that service that way, and so you don't want to be doing this for things you're adjusting regularly in production. In development, yeah, you write a couple of lines of code, you deploy it, see if it works, you go from there. Eventually you get to a final stage where you're not adjusting things. If there's a service that needs to be adjusted a lot, even after it's in production, that's not something to manage there. Yeah. Yeah. Nick.
So as kind of a follow-up to that, a more specific question is, for provisioning EC2s, CloudFormation, can you reference bootstrap scripts?
Yes,
Okay.
you can. You can do Bootstrap. There's a service called CloudInit that is also even better for managing that because it handles dependencies across installations of different things as you're going through. So you can do Bootstrap scripts. You can do CloudInit.
Okay.
Yeah.
Is that a good place, and then like furthermore, is that a good place to start considering not using CloudFormation anymore? Because especially if it's like, it's, you know, you gotta do version updates and all that stuff, like you're starting to move away from the resource side of things, right?
Yeah, well, I mean, if you're doing something with like a yum update, like for example, you can put that in the bootstrap.
Right.
And then,
But then you'd have to recreate your stack, let's say, if you had it included in the stack, reference to a bootstrap script that you just updated, right? So is that a good place to start thinking about, maybe that's not where I want to rely on CloudFormation to.
if you're making a lot of adjustments there over time, I would say, yeah, like I would consider like having that service like outside of that in a separate, its own thing. So either as its own stack, if it's like not that many changes, or something that like you consider taking out altogether. Yeah. Yeah.
So if I provision a bunch of EC2 instances and RDS instances with the CloudFormation template, if I go into the EC2 section of the GUI, will those instances be there, or are they in some special place?
They do exist there. So yeah, that is a good point in that what I want to show here, so here is the Kinesis stream that was developed by this CloudFormation stack that I've been showing you throughout this presentation. Here we have this, and it is, yeah, here's all the information. I currently have it streaming the Twitter data. And so, yeah, so here's that Kinesis. Here's the I created an S3 bucket here through the CloudFormation. It was just part of the template I was working off of. But yeah, it's got all that information. So yeah, it's all services are visible. Cool. So hopefully this is informative. Hopefully it didn't feel like too much, and like you could see how you might be able to apply this for managing your infrastructure as code. And so yeah, we'll go from there. Thanks for listening.
Thank you.
Awesome.